Now that's what is called an applied research question. And applied research is critical because it makes a difference in society. You're actually solving a problem. It contributes to what science can do for society. But there's another aspect to research, and that's basic research. So if you think about when people were studying quantum mechanics, that's basic research, trying to understand physics for the sake of understanding physics, because it's cool and it's interesting and it's exciting and it's contributing to the knowledge of the world. And a lot of times people don't quite understand the need for basic research. But if you think about quantum mechanics, without understanding that process, our GPS today wouldn't be working, right? That process is really critical to a lot of the technology that is available today. So our basic research question here is, how does this group of organisms called the Pseudomonas fluorescens group relate to each other? What makes up the basic organism within the Pseudomonas fluorescens group? People had started studying these Pseudomonas species for a long time, and they tended to group a number of different organisms into the Pseudomonas fluorescens species name. But as we have sequenced more and more genomes, we understand that this is not really one species, but that there are a number of organisms that fall within that species. And what we're trying to understand in our basic research question is, how do these different organisms that belong in the Pseudomonas fluorescens group relate to each other? How are they divided up in the family tree, if you will? So this is a phylogenetic tree, which is really a scientific term for a family tree. And we want to understand, for example, where would L5196 fall in this family tree, right? We expect that it's going to be close to the Q8R196 branch of the family, but we need to know that in order to do that, we have to know the sequence, which is what you're doing. The basic research question then we're trying to answer is, how do these strains relate to each other? Now this project was done by a group headed by Joyce Loper, and was a consortium of different groups, including Dr. Vella and Dr. Tomashow. And what they did was they sequenced the genomes of all of these strains that you're seeing here. So each petal represents the genome of one strain. And as you can see, these strains all have some things in common and some things that are unique to them. So that central circle there, the 2,945 genes, are common to all of these bacteria that belong within this Pseudomonas fluorescens group. So the 2,945 genes make up what is called the core genome. Then you can see that all the ones that are within the blue group, they have 3,968 genes in common. And then if you just pick out one, like P. fluorescens SBW25, it has 892 genes that are unique to itself. What you're trying to find out, so your basic research question is, you're going to identify between 2 to 4 genes in your sequencing reaction. So you're going to have 2 sequencing reactions for each of your DNA fragments. And the possibilities based on how densely those genes are divided up in the DNA, how densely those genes are coded for in the DNA, you expect to get between 2 to 4 genes. And your question is, do those 2 to 4 genes belong in the core genome? Are they common with a few of these other strains, or are they unique? Now, the question for you is, which one would you think would be most exciting? Would it be exciting to have the unique gene, the common gene between other strains, or that core genome genes? And I'll let you answer that question. So this is the basic research question you're trying to answer. This is related to the question of what makes L5196 such a good colonizer, but this is a slightly different question you're trying to answer, and that's the research that you're trying to perform. When you do your blast analysis and get your results back, keep this question in mind, these 2 questions in mind. One, is this gene or are these genes important for making L5196 such a super colonizer and able to survive in the soil? And two, where does my gene belong in the genome? Is it a core genome component? Is it common with a few other strains, or is it unique to L5196? And this is the team. There's actually a bigger list of people. So every student and every faculty member who's part of the CommGen Authentic Research Experience team needs to be on here, but it's a growing group. So I want to thank everybody who has participated in this program.